Well, hi everybody. Welcome to our monthly last Thursday of the month webinars. Um, Tonight we're going to talk about antenna distribution and why that's so important for your wireless mic system. So I guess to start, we need to talk about what is a distro and what is a combiner, because sometimes folks get these confused. They're sort of similar, but one works in one direction, the other one works front to back, and the other works back to front. So an antenna distro, or a multi-coupler it's called, is what you use when you have a bunch of microphones. And instead of putting antennas on every one of the receivers, you just use a pair of antennas typically into the distro. And then it doesn't matter how many microphones you have on the other side. Maybe that's limited, but it would be thousands you could use. So um, I don't know that there's a real limit to that. And what happens is that a pair of antennas collects the signals from all of those microphones and puts it into a box that redistributes it to all of your receivers so that you don't have to connect antennas to all your receivers. Um, this makes it nice. You can put it all together. You can permanently wire it. You won't have a rat's nest to wire. And usually with distros, certainly with our distros, you can power all the receivers so you can get rid of all those wall warts. A combiner, on the other hand, is what you use with in-ear monitors. And what a combiner does, it takes your in-ear monitor transmitters and sums them. So you plug your transmitters into a combiner. It sums them all to a single output, and now you can use a single antenna that will transmit to all your receivers. Um, this probably does have a limit. The more you use, the dirtier the signal gets. So this does have a limit depending on the quality of the gear, but I don't see too many people using hundreds of in-ear monitors, so we can make this work. One of the questions that I get, just in case it occurred to you, is, "Hey, I bought this Distro 9 and I've only got 5 microphones, but I've got 4 in-ear monitors. Can I plug them into the other channel?" And the answer is no. That's the wrong way. You have to use a distro to combine your for your wireless microphones, to combine your antennas for your wireless microphone, and a combiner to combine your transmitters to a single antenna, right? Okay, so now that we got that, why do we want to do this? Well, as always, this is my number one priority. This is what has to happen to make wireless mics and ears work. You have to be able to get your signal from the transmitter through the air into the antenna, down the wire, into the electronics, and when it gets all the way to the end, the signal from your transmitter needs to be at least 20 dB stronger than whatever the noise floor is wherever you are, at whatever frequency that happens to be. And when that happens, you get something called capture effect, and your radio locks to the transmitter, and your intended signal becomes the only signal that your radio sees. When you drop below that point, your radio is literally seeing every radio on the planet to some extent. So that makes it harder for the receiver to dig out what it's supposed to be doing when you're shoving so much stuff into the antenna. And this is kind of what that looks like. We have a noise floor. There's random RF noise everywhere on the planet caused by every radio that's turned on, every TV station, every CB radio, every burglar alarm, every RFID, every radio is generating noise, plus motors and computer chips and junk from outer space. So there's a little bit of noise down at the bottom. In your PA system, it would be the hiss or the hum, right? So in your radio system, you can't hear it, but it's radio energy. And so we got to get it above that red line, and that's what makes your wireless work. So that's why we're talking about using these combiners and distros, is that we want to improve that dynamic range. That's what makes it work. So if you look on the left there in the green, We got lots of nice gear stacked up. We've got distros, we've got combiners, and it's connecting all that stuff. And that's the way you want to do it. What you don't want is what you see over on the right side in the red. You don't want all those antennas hanging out there in an antenna farm. The one at the top is particularly bad because the antennas in the back are inside a metal cabinet, and that's going to block an awful lot of signal. Um, the guy at the bottom thought, well, I've got a nice, neat stack here. I've got all these antennas. But what he's not accounting for is that all those antennas that close together interfere with each other. That's what we're trying to get rid of. So we don't want an antenna farm like this. I see this a lot of times. Somebody will stack up two or three or four or 10 receivers on their mixing desk and have all the little whip antennas out like this. I got to say, this one is is horribly suspicious. But having fewer antennas reduces that noise floor, and it reduces multipath interference and signal cancellations, right? So the way that happens is your antenna, when it picks up a radio signal, when it's crossing the antenna, generates a current that goes down the wire into the radio, and we got a radio. But when you put that current in a wire, it generates a magnetic field. And until these antennas are about 6 feet apart, right, which would, if I had to split those 6 feet apart, it would take a really big desk, right? Well, I got lots of antennas. That's not, you're just never going to be able to do that. Whoops. So we need to split these apart by about 3 wavelengths or a little more. And that way the magnetic fields don't jump from antenna to antenna. When that magnetic field that you're generating jumps, it introduces noise into the other antenna. It's just nonsense, but it's noise. It's part of that noise floor. It raises that up, makes it harder for us to get capture effect, right? The other thing that happens when you put a bunch of antennas together, much like when you stack a bunch of speakers together, you get pattern control. You create an array. So when we stack speakers like that, we get a line array. Most people are familiar with that. And we can stack antennas in a mathematical sense and get pattern control. But when they're just stuck all over the place like they are here, they interact. Who knows? The antennas actually change their patterns. So who knows where they're going to go? And what that typically means is if you think about your stage, you're going to have hot and cold spots on your stage. So as you're walking back and forth, your signal is going to go up and down and up and down and up and down because your antenna coverage is going up and down, right? A third thing that happens is that it's something called reflected power. So when a radio transmitter, when the signal goes into the antenna, again, it goes down the antenna into the radio, and we got radio. But the way radios work, they push back some of that power back out the antenna. So your antenna is actually transmitting a little bit of the energy while it's receiving the energy. And again, if you have another antenna close by, well, that antenna is kind of screaming that energy into the other one's ear, so to speak, right? Again, it's creating more and more noise. So what we want to do is use the fewest number of antennas, which in a normal size room that we'll call 1,000 or 1,500 or maybe 2,000 people, you should have one A and one B antenna. Adding extra antennas will not make it better, it will make it worse. So what you want to do is to use a distro. Here's a couple that we make. The top one, our distro 4. It could have been called a distro 5, I guess, because it has 5 outputs, 1, 2, 3, 4 in cascade, which with our units is an active buffered output. It's not just a passive split. So you put your A and your B antenna into this, and with one box, you could control up to 5 receivers. It also has the little power jack, so you can put power, well, in this case to 4. The cascade is to join them together. And then we make a bigger one called our distro 9. You can see it's got more bells and whistles. It is an extremely high quality unit. So if you have a bigger channel count, or you have, or you're in a particularly difficult area, if you're in a metropolitan area where you get a lot more interference, maybe. And then, of course, you can stack these distros together. Our distro 4, you could connect 6 of them and get 25 channels. Our distro 9, because it's a whole bunch cleaner, you could actually stack 10 of these together and get 81 channels. So something to think about if it's really, really, really important that you have the highest quality, or you have high channel count, or you're in a difficult area that has a lot of RF interference. That would be worth going to that one. So one of the other things, when you use a distro, that allows you to remote your antennas. And so you can use directional antennas, which are almost always preferred, right? It's the same way, you pick a microphone for your singer, you probably pick a cardioid microphone that picks up in one direction, and you point it to the singer, and it rejects information from the backside. So it's the same way with antennas. You end up with a directional antenna, like a paddle. You can point it at your transmitter, or assuming your transmitter is all in the same place. Most of the time it's on the stage, right? If you use a whip antenna is omnidirectional in the horizontal plane, so it's going in all directions. So if you have whip antennas on your receivers, and let's say you're at a mixing position at the back of the house, your antenna is going in every direction. Your antenna is going behind you, sideways to you, and that means it's going to find more interference, right? So typically, a whip antenna is going to find more than twice as much interference compared to a directional antenna, assuming that the interference is equally distributed, and which it usually is. So you're much better, pointing an antenna directly at your transmitters. Now, if you're doing theater in the round, well, that's a different story. Or if you can locate your antenna in the center of your venue, then that's fine. But you don't want to put it in the back against a wall. Well, for example, if we thought about a football field, if I put my whip antenna where it belongs is in the center of the 50-yard line, right? And that way I pick up the whole field. If I were to move that antenna down to the end zone, it still would pick up the field, but it's going to pick up the parking lot that's behind the field. And inevitably, there's more RF junk getting into my signal. I don't want that. So I don't want to pick up anything except my transmitters. So when you can remove the antennas from the receivers themselves, and you can get a directional antenna, you're going to pick up a lot of extra benefit from the directional antenna. I mean, I guess you could buy a whole bunch of directional antennas, but that would be way more expensive. And actually, you'd still have to spread them far apart. They still would fight each other. So what you want to do, we resolve this now down to 2 antennas. So you should use an A and a B antenna inside each enclosed space. If you have multiple rooms, you should have an A and a B antenna in each room. I mean, it will pick up through walls sometimes, some amount, might be enough, might not. Not a good way to design a system. You got to get lucky. But this is what happens. The other thing is when you use a directional antenna, it has gain. So you're going to pick up a stronger signal from the transmitter than you will with an omni antenna. And you can see that if we compare the 2 signals, it's almost going to be double from a paddle than it would be from a whip, which means it's getting farther up out of the noise range. The noise is kind of the same all the way through the room. So you're picking up more of your direct signal. And that's always a good thing. That's going to make it a whole lot more reliable, right? Okay. So I want to talk about this because this is probably the worst thing you could do. In this particular picture, this guy has wireless microphones and in-ear monitors in the same rack with all the antennas. So the problem with this is that the in-ear monitors are transmitting, right? So they're sending out pretty high power to the wireless microphones are expecting to see very low voltage, very tiny amount of power because it's got to travel and get there. Um, your in-ear monitor transmitter, on the other hand, is putting out a lot of power so that as it travels, and because you lose signal with distance, same way as you get farther away from the speaker, it gets quieter, right? Well, when you get farther away from the transmitter, the signal gets weaker. That's very similar. But if you have these two things together in close proximity, you're really uh, running the risk of overdriving the front ends of all those radios. So um, you really need to, receivers and transmitters need to have some distance between them. If you put a receiver right up next to a transmitter, you'll well overload the radio. So I think in every owner's manual I've ever seen for wireless mics or ears, they're going to tell you to be 6, 10, 12 feet away from the antenna. Because if you get closer than that, again, it's the same way with your PA speakers. Nobody wants to sit a foot and a half in front of the speaker stack, right? It would just blow you away. But you get out 20 feet or 50 feet and it sounds the way it's supposed to. So kind of the same thing is working um, with this kind of a situation. So people ask me all the time. So it's fine that the transmitters and the receivers are in the same rack, the physical units. The problem is you can't have the antennas together, right? That's what we're considering. I don't care where the receivers or the transmitters are. I care where their energy enters or exits, right? So I care where the antenna is. That's the important thing. So in this case, oh, this guy should either, as a minimum, have a distro for his wireless mics and then move those antennas someplace else, or he should have a combiner for his in-ears and combine that to a single antenna that he can move away from the other ones. So this is very similar. You think about it the same way you think about a microphone and a speaker and getting feedback, right? If I point the microphone at the speaker, so I'm picking it up, I'm much more likely to get feedback if all I do is turn the microphone around backwards, assuming it's a cardioid microphone, then my chance of feedback goes down dramatically. So you want to be able to do the same thing. You need to separate your in-ear uh, transmitting antennas from your wireless microphone antennas. And again, all antennas, whether they're transmitting or receiving, would really like to be about 6 feet, maybe 10 feet apart from each other so they don't interact too much. I mean, obviously, this must be working for the guy, right? I assume, he's done this and it's worked, but it's barely working. And you just have to wait until you get to that one time where you have just a little more interference in your audience. Or if you're traveling, you get to a venue that isn't as interference free as the last one. And this system is going to drop out and sound bad way before it needs to. So, if we go back to that first slide, if he's got 20 dB of isolation between all these things, he's going to be on the air. But he has really tied both hands behind his back and put a ball and a chain on at least 1 foot. I mean, this is really, um, uh, like I said, it must be working, or either that or the first time he turned it on, he had to take this all apart. Because sometimes what you can get away with, you can get away with. You can do it wrong if it works, right? But just just wait until you really need it. Actually, one of our new tech support guys told me the other day something I hadn't thought about, and that's that. If you're working 99.9% of the time, we'd go, wow, that's really good. That's nearly perfect. But if you think about that, that means you have 4 seconds of dead air in every hour. And that's unacceptable. 4 seconds of not being on the air is going to make a big difference to singing your song or telling your sermon or whatever it is you're doing with these microphones. You just don't want that to happen. So, for every place else in your life, if your car worked 99.9%, you'd say that's great. But with your wireless mics, that's not enough. So we're really trying to make this completely bulletproof. And so by doing all these best practices, that's kind of how we end up. So again, you use a combiner. So with this, you plug your transmitters into this, and it resolves them all down to a single output. And then you can use a single antenna. Hopefully, you're using a circular polarized antenna. We've talked about that. That's the right kind of antenna. A whip and a paddle um, are very limited for in-ear monitors because they can't track as you bend, right? So if you always stayed perfectly straight up, if we tied you to a pole, it would be fine. But people are going to move and bend and twist, and so linear antennas, whips and paddles, are not a good choice for wireless microphones. Excuse me, wireless in-ear monitors. If you move from that to a circular polarized antenna that we've talked about on other things, and there's plenty of info on our website about those, you will greatly improve your your in-ear monitor reliability. And again, you have to use one of these combiners because circular polarized antennas are more expensive. They're harder to build. You don't want to have to buy one for each transmitter. Way cheaper to do it this way, and you'll get better results. So, so, so let's talk about it. Because antenna distribution might seem like an added expense, but it's really a crucial investment for anybody that has a few wireless microphones and a desire to ensure reliable performance with minimal complications, right? So by switching from a pile of antennas from an antenna farm to distros and combiners, you're going to get better performance, more reliability. Things are going to work the way they started out, right? You're going to get a cleaner signal because you can use better antennas. You're going to get a cleaner signal just from the distro itself, but you also can improve that system by using directional antennas. Uh, Obviously, simplified antenna placement. You don't have to hook up 27 antennas. You're just hooking up three, right? An A and a B for your wireless mics, and hopefully a circular polarized antenna for your in-ears. It allows you to put all this stuff in a rack and lock it down. The distros and the combiners all have DC power for your transmitters and receivers, so you don't have a pile of wall warts on, 6 different Weber strips trying to get that all plugged in. And again, you can move the antennas out of your rack and get them where they need to be. You can move them, getting antennas closer to performers is a really good thing to do. Again, think about it the same way with a microphone. If I'm going to pick up a singer with a microphone and that microphone is 6 inches in front of their mouth, I'm going to pick them up very well. If I move that microphone 10 feet in front of them, it's still going to pick them up, but it's going to be very weak. And if I move that microphone 50 feet back, it's still going to pick them up, but I've picked up so much more noise and other garbage with it. So getting your antennas closer to your transmitters again improves that signal to noise ratio, which is so critical to keeping all this stuff on the air. And this allows you to do it. I mean, how would you move 27 antennas closer to your transmitters? That would be a nightmare to try to do. So, just improved performance and reliability obviously is the ticket here. Everything else is a benefit, makes life easier. If you had all that stuff like all those receivers out on a desk, you got so many wires floating around in the middle, things are going to get unplugged and bumped. So you do want to be able to rack all this stuff up and lock down all your wiring and everything. And so that's what a distro or a combiner is going to do for you. So with that, I think I've covered everything I intended to say about distribution. If you have any questions, there's a question button on the bottom there that you can click on and ask. Uh, no question is too dumb. Ask away. We all got to learn. And so happy to answer those. And then, of course, we always ask when we send out these invitations, we ask for questions. I think I've covered most of them in the presentation itself. Yeah, so if you didn't you didn't hear your question asked as a question and answered, I think most of it was built into that presentation. But we have some other ones, Adam. So
Yeah,
what
absolutely. And I apologize. I forgot to call at the beginning that you can go ahead and punch in those questions to the Q&A box and I'll happily field them. But looks like we're getting some questions now, so I can call out the questions you've submitted as well as your live questions now. I'll go
okay?
ahead with the easiest one. So Gordon asks right now, it doesn't look like the Distro 9 has DC power. Is that right?
No, it isn't right. Let's see. Go backwards to all these. Yep, I think I went too far. I definitely went too far. There we go. Um, so at the top, just to the right of center, you can see a black and red set of terminals. That's called an Anderson power pole connector. That's a high current connector. And what we have is we call it an octopus cable. You plug it into that, and then it has 8 tails that comes out of it that you can plug into your receivers. So yeah, the Distro 9 will give you up to 5 amps of current.
Awesome. Thanks, Don. So here are the pre-submitted questions. So the first one is, why would you experience dropouts in IEMs even though you are already using a combiner and antenna?
Well, there's a number of reasons, but the most likely one is your channel assignments aren't as good as they could be. So there's two parts to making a radio work. And RF Venue, we can help you with one. We can make sure that your RF signal, your RF energy, gets from point A to point B nice and clean and nice and strong. But even when that happens, you have to have a clear space to set the frequencies of your transmitters and receivers. Um, and the more of those you have, radios all interfere with each other. So you find an empty space for one, and then you find an empty space for number two. But setting that frequency compared to frequency one, those two channels may interfere with each other. So if you're using in-ear monitors and you're using wireless microphones, we have to count the total number of units that you're using. So if you're using one mic and one ear, it's pretty easy to do. If you're using 12 mics and 8 ears, that's a whole nother story. And what you need to do, you need to use a frequency coordination program. We have a free one on our website. If you go to rfvenue.com, there's a button on top of every page, a round button that says performance tools. And you can click on that and that'll take you to two. You want to use the one that says build your system. And then you tell it where you are, you tell it what brands and what blocks of wireless mics and ears you have. And then you push a button and it's going to give you a coordination for that site. So that would be a good first step. That works a whole lot better. People use the built-in frequency finders. Well, they don't work. The world is a little different than it used to be, and so they don't work as well as they used to. And if you're mixing brands or you're mixing blocks, that screws them up even worse. So if you're using Shure microphones and Sennheiser in-ears or whatever, something like that, or you're using, 3 brands of wireless microphones and 2 brands of in-ears, it doesn't play nice with those automatic frequency finders. Just use that web app. You don't even have to download it. You can do it on your phone when you get to a gig. So that's real simple. So that's probably most of your problem is probably intermodulation distortion. In other words, those frequencies working against each other that would take you off the air.
All right, awesome. Next question. If one particular band member's IEMs are always more problematic in terms of RF hits than the others, what could cause that?
Well, the most likely thing would be that he's too close to the antenna. So I don't know what your setup is. So usually it's the guy, if the antenna is over in one wing at Monitor World, and you got a guitar player way over on that side, the signal could be hitting him so strong that it's folding over the front end of his receiver. That would be the most likely thing. I've seen drummers have problems. Believe it or not, cymbals seem to be an issue sometimes, and it could be that. So I mean, if one guy's having problems and he's got clear line of sight, so that's the important thing. The transmitters always need to be able to see the receivers. So if you've got a set piece or something in between that, that would cause a problem. But my guess, the most far by far, I guess, the most likely problem is that he's too close to the antenna.
Got it. All right, so let's see here. According to Shure, their antenna distribution already has a frequency filter. Is there a reason to add the RF venue bandpass filters?
Yes. So all radios have some filtering in them, but filters have slopes. In other words, how quickly they fall off, how quickly they stop. So a filter doesn't take you out to a frequency and then cut it off. That's what we would call a brick wall filter, and that doesn't exist. And the closer to that you get, they have other problems. But what they probably have are first or maybe second order filters. So if you know a little more about speaker crossovers, that would be 6 dB per octave or 12 dB per octave. Our bandpass filters are 36 dB per octave. They're sixth order filters. So they're very steep. They get to that end frequency and they cut it off very quickly. You don't want, if it's only 6 dB per octave, that means for the whole next octave. So just for example, if the top of your filter was 600, at 1200, you'd only be at half power. In other words, it's filtered, but it hasn't filtered very much. And the reason that they don't put higher order filters is because they're very expensive. So they'd have to put one on every channel. So it's better just to use a separate set of filters is almost always much, much more effective.
Cool. This is the last question that's submitted. Is it possible to use multiple brands at the same time with the RF venue combiners?
Sure. You can use multiple brands of anybody's anything. So remember, what we're talking about now is the RF section, the radio waves. And radio waves are a universal force of nature. Electromagnetic waves simply are what they are. And so nobody has a proprietary brand. Nobody has their own that you have to use. So as far as the radio waves go, yeah, you can plug a Shure antenna into an RF venue distro, and you can run it out to a Sennheiser digital wireless microphone and an Audio Technica analog wireless microphone all at the same time, and it makes zero difference. As long as they're in the same frequency block, but it's pretty hard for that to not happen. So yeah, you can mix and match. You don't have to match logos at all. Um, there you go.
Gotcha. So we've got all the questions. So if there's any questions now, go ahead and put them in the questions and answers, and I'll call them out as we get them. We have a few more minutes here.
And actually, the questions can be on any other topic too. That's fine. It doesn't necessarily have to talk about distros. Anything else you'd like to talk about with wireless mics? Because we all face the same problems, right? Wireless mics these days are much, much more of a challenge because we have such limited bandwidth. We just don't have as many empty spots as we had. So the freeway is filling up with cars. There's not a lot of space to put more cars in there. So we got to be really smart about how we get to them. So anything to do with wireless, I'm sure, whatever your question is, somebody else is having the same problem. So,
There you go. Here's a question. Recommended minimum distance between mic transmitter and antenna. It certainly comes up often.
so um, it depends how strong the transmitter is, and it depends how much gain the antenna has, right? So if you have a transmitter that's twice as powerful as another one, you need to be twice as far away. Likewise, if you have an antenna that has twice as much gain, you need to be twice as far away. So radio signals diminish at the same rate that sound does, right? So as you get farther and farther away from your speaker, um, it goes down by what we call inverse square. So every time you double the distance, you cut the power to 1/4 of what it was at the distance before that, right? So at whatever power level you have based on how strong your antenna is and how powerful your transmitter is, at 10 feet, if you move to 20 feet, the power is now 1/4 of what it was. And then you simply just have to have enough that your radio isn't always hitting full power. In fact, um, you don't really want to be hitting full power all the time, right? When you're setting your system up, you go turn it on, you look over there, and I got 5 red lights. I'm all the way to the top. Well, that's a little dangerous because inevitably somebody's going to get closer to the antenna and have even more power into it, and then their audio is going to start getting ratty. It eventually will drop out, but it probably click and pop before that. So you don't want to overdrive it. 3 or 4 lights, you're good to go all day, right? I mean, you're still getting plenty of power to the receiver. So maybe when you set up, if you're getting full power like that, one of the little tricks is to add pads to your antennas. Okay, that seems entirely backwards. You don't want the strongest antenna possible. You want an antenna that's just strong enough to get to the distance you need, right? So if you had an antenna that would go for a mile, and the farthest you're ever going to be with your wireless microphone from the antenna is 100 feet, then what happens is that antenna is picking up a mile less 100 feet of extra noise, whatever noise happens to be out there. That antenna is picking it up. And that goes back into the pile. Remember, we're trying to hit that 20 number. So we're adding more noise in that system. I don't need to pick up anybody a mile away. So I wish there was a way I could make my antenna go out to that 100 feet and at 101 feet stop, but it doesn't. It tapers off. Um, but we can put pads in our antennas. We can actually turn down the signal coming from coming from the antenna going into the distro. If we talk about the wireless mic part, let's talk about that. So, wait a minute, didn't I say it had more gain? Yeah, but if you put a 6 dB pad from your antenna going into your distro, you turn the signal down by 6 dB, but you're also turning the noise down by 6 dB, right? So we're still good on our dynamic range, and actually we've made our radio better because the lower noise you put into it, the better the sensitivity of the radio is. So you actually are improving the radio sensitivity when you have lower noise going into it.
Very cool. We've got some more questions coming in.
Okay.
How do you calculate insertion loss when connecting IEMs to one combiner and two combiners cascaded?
Okay. So if you use a passive splitter to combine um, two combiners, so if you had two combined fours and you used a 2x1 splitter to combine them to a single antenna, right away, the act of using a splitter uh, gets you 50% of the power, right? It's easy to see on the way in, but on the way out, it's a little more, excuse me, easier to see on the way out. But it works when you run through a combiner. If it's a two-channel combiner, you're splitting the power 50-50. That's just what happens. You're splitting the power into two. Um, there's also something called insertion loss, and that means that's resistance. That's like, your wire's got some resistance to it. So your filter, your combiner has what's called insertion loss, and that's probably with ours, I think it's about a dB and a half. So you've lost 4.5 dB of your signal. But again, with in-ears, God, you have so much more power than you need. I mean, if you're only trying to hit somebody 100 feet away at 10 milliwatt, you can just turn the power way down. So that loss of power, while it seems scary, it's what we're really, excuse me, the loss of, so you're losing voltage, but what I care more about is dynamic range. And I can lose a lot of voltage before it becomes a problem regardless of what the other guys tell you. That's really, I mean, there's a point which the voltage makes a difference, but I don't see it. I mean, in anything that I'd consider normal, you got plenty. You got more than you need. So it's fine that you can give some up. I mean, you're also, if your antenna is not perfectly focused at your receiver, you're losing power. You're losing it all over the place. There's lots of places you're losing it, and it just works, doesn't it? So I wouldn't worry about that too much. There's a point, if you want to do something drastic, but losing losing 6 dB or even 10 dB of signal probably isn't a big thing in the overall picture. It again, it depends on other things as well. But I wouldn't worry about it very much.
All right, awesome. So unless anyone has any further questions, that's all she wrote, folks. And again, we appreciate your time as always. Thanks for hanging with us. And it's great to see that there's been some new people checking out our webinar. And we hope you join us on the next one. We do these monthly, so watch out for the next email to schedule that. And we appreciate your time again. So thank you very much. You can always
I
reach
would,
out to us directly if you need to. What's that,
yeah,
Don?
if there's a topic you'd like covered, just send it to adam@rfvenue.com or to don@rfvenue.com. And I mean, we're looking to see, what help people need. So yeah, if you have a topic you'd like to suggest, or you can just send us a question anytime, that's fine too. We're happy to answer it.
Absolutely, Don. Great. And yeah, so that's all she wrote, folks. And thanks again. Hope you enjoy the rest of your day and week. And we'll talk to you soon.
See y'all.
Here, guys. See ya.